Hello everyone, Professor Dustin here, and this video is going to be kind of like a crash course in spreadsheet analysis. So a big part of what we're going to do this semester in the advanced lab is collecting data and analyzing data. And there's lots of great programs out there for analyzing data. Um, Spreadsheets is not like the best one as far as power goes, but it's the best one as far as simplicity goes. And it really does a lot of sort of things that seem really simple and trivial, but actually when you're working with a lot of data, the ability to like calculate an entire column all at once or adjust parameters for a model that you're using is just so powerful that you cannot escape how fantastic spreadsheets really are. So I'm going to give you just like the essential tools that you're going to need. I think this will basically be all of them that you're going to need this semester in the advanced lab. As far as using spreadsheets. So some of you may be very familiar with spreadsheets and you can just pass over this video. That's okay. If you're not familiar with spreadsheets or you think this video has things in it that you don't know, my advice is to pull this video up and pull up a spreadsheet program. I'm going to be doing Google Docs, but everything I'm going to be doing is very similar in the other spreadsheet programs like in Excel or whatever. Numbers, I think, is the Microsoft one. So is the Mac one. So I think having a spreadsheet open with you and doing the things that I'm doing in the video is going to be the most efficient way to learn this stuff, because it's really like you have to do it or you're not going to see like even what the benefit is of the thing I'm describing. So anyway, I have a Google spreadsheet opened up here. And the first thing we're going to do is talk about, the essential process that we're going to do is taking data, right? So maybe at a particular time, we want to find the position. At a particular position, we want to find the voltage or whatever, like anything. Even from the very beginning, spreadsheets can be incredibly useful in that process. So for example, we may want to take data of time and position. Like maybe we have a kinetic object, let's slide down a ramp or whatever, and we want to find these, we want to measure these two parameters. Now, if you are measuring at arbitrary times and you're picking up arbitrary positions, maybe spreadsheets can't actually help you because at some point you're going to have to type all the information in. But it's very likely that we'll be like taking position measurements every like 1 second, for instance. So in that case, say I have like 50, I want to do it over 50 seconds. I've got 50 numbers to enter here. I've got 0, 1, 2, 3, 4, 5, 6 for every second, right? Okay, that's easy, but it's going to be annoying. Spreadsheets can even help with that. So start with 0. You can, in the next cell, tell it to take the previous cell and add 1 second. So the way I'm going to do that is I'm going to push equals. That tells me I'm going to write an equation. Instead of writing 0, I'm going to write take the value which is in that cell, A2, and add 1 to it, plus 1. Hit enter, and you can see that it answers 1. Of course, because it's A2 plus 1. A2 says 0. Sorry, 0.0 plus 1 is 1. Fine. But what's great about spreadsheets is when you cut and paste with spreadsheets, this number, this 2, increments. It increases every time you hit copy. So if I do highlight that cell, Control C for copy, click that cell, Control V for paste, and you can see it's not that it still says 2, it says A3 plus 1. So it increased the 2 to 3 when I went down 1. You can do that for all of the cells. Control C, and you can highlight a bunch of cells, Control V, and you see you're just counting by integers. So this seems kind of dumb at this moment because those numbers are almost the same as these numbers here. So maybe you could just use those numbers there. Okay, fine. But what if we're taking measurements every 10th of a second or something? Well, it's very easy to change your the setup to do that, which is right equals the cell and then plus 0.01. Right. And you can see they've all changed, but they're all changed because the other ones still have 1 in them, plus 1. So you have to copy the one you made, Control C, and then what I'm going to do is I'm going to hold Shift while scrolling down to get down to, sorry, you have to be a little careful with that, to get down to, don't hold Shift while you do it, scroll, then hold Shift, and then click the bottom of the column, then Control V. And then you get your times all the way up from 0 to whatever, 3.3 seconds, where I arbitrarily picked, 35. Okay, fine. So that was already helpful, right? It was already a little helpful to write down immediately a time series, which was ordered by very specific intervals. Cool. So this next line, like if I'm going to take this measurement, there's really nothing that spreadsheets can do to help us get numbers in here, right? If I'm measuring the position of something, spreadsheets can't tell me what that measurement was. I have to just go out and measure it, and then I have to type it in, right? So, okay. So what I'm going to do now is I'm going to type sort of random numbers into that position. If you're following along, kind of do the same thing. I'll probably fast forward this part of the video because it's not that fancy or great to see me type random numbers in, but I'm going to start typing some random numbers. Okay, some random numbers. And really, I just want to get some data in there. I tried to make them kind of linearly increasing, but it doesn't really matter. Okay, so let's say this is the set of data we have. And the next thing we want to do is let's say we want to find the velocity in meters per second. So you know what the formula for velocity is? Change in position divided by the change in time. So maybe I could do like this guy minus that guy, divided by that guy minus that guy. Fine, that would work. But if I'm doing that on a calculator, I have to do that 30 whatever times. I'm starting at row 2 down to 35. So there's 34 numbers. Differences mean I'm missing one. So 33 times, right? I have to do that in my calculator 33 times. That sounds like kind of a nightmare. This is really where spreadsheets can help us. So what we can do is we can put a formula into the spreadsheet, one formula into one of these cells, and then copy and paste it down to all the cells, and it will increase the cell numbers. And so it will automatically calculate every single line for us, which is like enormously helpful. So here's how we do this. Put an equal sign. Now notice I can't do it in the first one because I don't know what the position was and the time was before the first one. So I have to start with the second one. So this is going to be change in position. So equals, I'm going to do a formula. Parentheses, final position minus initial position. That's the numerator. Denominator is final time minus the initial time. And notice I'm being very careful to enter the cell values, not the actual values that are in the cells, right? B3 and B2 refer to whatever is in those cells. A3 and A2 refer to whatever is in those cells. A2 is 0, right? But I didn't want to put 0 because then 0 will be fixed the whole way, whereas what I want to do is I want to update the values for all the new cells. And you'll see what I mean when I do this. So hit enter. I get a number, and look, Google tries to do this. Hey, is this really what you want to do? I don't really trust the autofills, so I always skip them. It's very likely those are all correct, right? Okay. So look what it says. It says take whatever's in that cell, subtract whatever's in that cell, divide by whatever's in that cell, subtract by whatever's in that cell. Cool. If I do a Control C, move down, do a Control V, that's a different number, but notice that these cells increased by 1 for each thing. Increase from 3 to 4, 2 to 3, 3 to 4, 2 to 3, right? And so now this is calculating that minus that, divided by that minus that. Cool. I can just copy and paste that all the way down. Notice the way I'm doing this. I did a copy on that, and then I use the arrows to go to that one, held shift and push down. And I just scroll all the way down to the bottom. So that's a quick way of getting down to the bottom. Once they're all highlighted, Control V, and bam, that's the velocity of my particle at all those times. Pretty cool, right? And actually, this allows you to update things. Like, what if I was like, oh, actually, the position wasn't actually 0, is a little bit more. I think it was 0.5. That number changed. Awesome. I don't have to do anything. So that's the number one most powerful thing that spreadsheets can do is update and do a whole bunch of calculations all at once if they're repetitive, right? Okay, let's say we want to do something else. Let's say we want to find out what the kinetic energy is of this object in joules. So kinetic energy is a pretty easy formula, 1/2 mv squared. I can't calculate it there because I don't know what the velocity is there. Ooh, and I should say at this point, if you're sort of worrying a little bit about this velocity calculation, because this velocity calculation was using the time interval between 0 and 0.1, but I'm assigning the velocity at 0.1. That is probably not right. What I probably should have done is put a time interval in between these two, like 0.05, and assign that 6 meters per second to that in-between interval, right? Because it's the average of these two positions, so it really should be in between. That's what you do for a real good lab. This I'm just trying to like show you spreadsheets, right? Okay. So if I want to do kinetic energy, I have to start here because I don't have value for velocity there. So I'm going to do equals 1/2. And then I need to say what the mass is. Well, okay, let's say it's got a mass of 2 kilograms, just arbitrarily, right? Times V, velocity is there. If I reference the cell, I'm going to be able to do this cut and paste thing. So I'll reference the cell by clicking it. Squared, caret squared. Hit enter, and then we got a function. Again, it's trying to get us to autofill. I'm not going to do that, but I can copy, paste that entire thing, and then I immediately have the kinetic energy. And now I could do cool things like plot the time versus the time A versus the kinetic energy D, and actually get numbers for something that would have taken me like 20 minutes to do the calculation for by hand, right? Okay, so that's good, but let me show you one other powerful thing about Excel, which is like, let's say that we don't know what our mass is, or that we want to apply this same sheet to a different mass. That means we don't want that 2 there. Now we could delete the 2, replace it, recopy. That's not so hard, but what's really great about spreadsheets is it allows you to do something called parameters. So a parameter is something which like doesn't vary as you do the experiment. So everything here is varying. Time, position, velocity, kinetic energy, all varying. But the mass isn't, right? That's why I could put that 2 there and just cut and paste it downwards. But what if I have a different mass and I want to apply it again? I can go down, and I usually put them at the bottom. Some people like to put them sort of up here. I like to put them down here. I'm going to label a mass in kilograms. And here I'm going to say, well, it was 2, right? But let's say that the mass is actually like 4.15, whatever, right? Okay, I want that to go into my formula. So that seems pretty straightforward. I go up here, instead of the 2, I could type in 4.15, but I want to reference that parameter to use this copy paste thing. So I'm going to click that cell and then click return. Okay, so it did update 74.7, clearly bigger. Okay, so now what I'd like to do is again do the Control C, cut, paste all the way downwards. And I'll show you this isn't going to work. So I won't do the whole thing. I'll just do the first one. I'll do Control V. I got a 0. So that's clearly not right. I mean, the kinetic energy is not 0. It is moving. It's got a 3 meters per second velocity. What happened? Well, you can see what happened when I cut and pasted from here. It went from B39 to B40. That's what the spreadsheet wants to do, but there's nothing in B40, right? It increased the number of the cell, but there's nothing in that cell, so it didn't work. So what we need to do is we need to figure out a way to tell the spreadsheet to not increase some cells when we do the cut and pasting. And the way you do that is you surround them with dollar signs. So everything in here can be increased, so you need to surround everything you don't want to be increased with dollar signs. So $B says don't change the B. $39 says don't change the 39. So that's the correct formula right there, is the dollar signs. Now, if I do a Control C, Control V, the kinetic energy correctly increases to 18.675, clearly bigger and it stays at B39. So what's interesting is you can actually see this gives an example of like another thing spreadsheets can do, which is instead of increasing the number value on the cells, it can actually increase the letter value too. So if I do this, Control C, and then put here a Control V, you can see that what it's doing is this is going from C3 to D3. So it's increasing the cells to the right if you cut and paste to the right. If you cut and paste downwards, it increases the cells downwards. Now, of course, I don't want to do that right now, but I just want to point out that you can cut and paste both ways for like utter power. Okay, so I've done this. So now I want to just get all the rest of these cells to be the correct formula. Cool. One final really, really cool thing you can do here is now that we have these formulas which reference that B39 cell, I can go down to that B39 cell and change this value and it will immediately update everything without me having to do anything. So let's say I was like, oh no, I got the mass wrong. We remeasured, it was 4.25. Now I have to redo all this work. Nope, 4.25. Everything gets updated immediately. So that's a super powerful way of making that parameter changeable without having to redo any calculations. And I do generally advise get into the habit of setting your spreadsheets up this way whenever possible. Not always possible, but when you can, it can be a super powerful way of fixing your mistakes. Okay, anyway, so those are the two most important things about doing spreadsheets like this, which is that the cut and paste thing and then the parameter thing. I want to show you one more thing, which is how to put in more complicated formula. So one thing we're going to do this semester is line fitting, because sometimes we have data that we want to fit to a particular model, like a line or a curve or an exponential or whatever. You can do that on sheets, and I'll show you how to do it real quickly, but the real quick way doesn't get you all the info you really want. Sometimes you want to put it right into the cells itself instead of onto the graph. So the way you do that is with a formula. So equal says I'm going to put a formula in, and I always forget what the thing is called. So I always type LIN because it's like a line fit of some kind. And you can see the options come up. Line ST is what I mean. Best fit linear trend. Click. And what's cool is it shows you exactly what it's expecting. It's expecting 4 options for known data, calculate, be, and verbose. Okay, so I'm not sure exactly what all these are, but some of them I do know. Known data X and known data Y. So known data Y is going to be the vertical axis. So in that case, this is our, let's plot velocity versus time. So this is going to be velocity, that right there. And notice I have to be a little careful not to get this cell because there's no data in that cell. So I want to actually start here. And what you do is you scroll downwards and then hit shift and then click on the bottom, and you can see it auto populates the entire range in there correctly. Hit comma. I know it's a comma because the program, the function is saying I am expecting some data, comma, some more data, comma. And so now it's telling me, ooh, now you got to put in your data X. So that's going to be the time values. Again, started at exactly the same place. Don't grab the one before because there's no data in the velocity for that. Scroll down, hold shift, click at the bottom, and you get all the data you need. So the next two things, in principle, you might need to like go to the internet to figure out what calculate B and verbose are. I'm going to take a guess and that they are true false flags. Like yes, calculate B, which is the intercept, mx plus b, or yes, calculate verbose. So what I'm going to say is true, true. And I think that's the right way to use this function, but I will show you how to check it in a minute. So let's hit enter. Cool. So clearly it did something, right? But it spat out a whole bunch of numbers that we might not understand. So let's go back up here. And sorry, I had to change my Zoom docking. So, and just Google, see what I Googled, Google Sheets line ST, and I spelled it wrong. There's the right spelling. Okay, Google Sheets line ST. Click that help, and it tells you, here's the usage. You do what we did. Well, sorry, we did what we did here. We put true and true for those two things. Turns out you can also just enter the data without the true and true. So let's see if that works when I try it. So just get rid of those things. Cool. That just tells me two things. So we should obviously know what those two things are. And below it, it tells you all the things that you can plug into this function. Known data y, a range containing dependent variables. Known data x, same as, sorry, these values are independent variables corresponding to known data y. No problem, right? What are the other two things? Optional and optional. Calculate B is given a linear form of that, calculates the y-intercept of true. Cool. So if we want to find the y-intercept, we pass true to that part of the parameter, the third spot in the function. Verbose, optionally, it's normally false. A flag specifying whether to run additional regression statistics or only the linear coefficients in the y-intercept. So that's a little bit like we have a whole bunch of data there, but if you scroll down, it tells you everything that's going on. So if you have the formula is data, and actually remember ones and zeros is computer language speak for true and false, where one is true and zero is false. So I wrote true and false, but you could also write ones and zeros here. This is the slope, and this is the y-intercept. So if I have nothing in there, I have a slope of 6.92, right? And a y-intercept of -1. Cool. But what if I want more data? True is actually the default, so I'm not doing anything by writing true. But if I write true, I can get the entire statistical analysis of this. And in fact, if I go down here, all of these things are described in this box right here. So that's the slope, that's the y-intercept. That 1.62, 0.162 is the standard error of the slope. We got a standard error for the y-intercept, lots of stuff, right? So if we want the full analysis, and this will tell us how good our fit is. In fact, if I go back up here, I can look at, this is the error on this guy. 7 plus or minus 1 is like not that great. -1 plus or -2, also not that great, right? This is because the data I came up with was like basically random. It's not really a good line, right? It's a bunch of random data. In a second, we'll actually look at it so you can see how bad it is. But anyway, most of these statistics we don't need, but actually the standard error values are incredibly important. If our error is the thing we want to get, like say we're doing, if the slope is something that we want to get, like say we're doing a plot of a falling object and the slope is the gravitational acceleration, and that's what we're trying to find, we want to know what the error is on that, right? And so this will actually tell us. So that's very cool. Okay, so that's how you do functions generally. Just type stuff and look for what the program tells you to do next. But also here's how you do the line fit, which we're going to have to do several times this semester. Let's real quick while I'm here, in case you don't know how to do plotting, I want to plot time versus velocity because that's the fit that I did right here. So I'm going to click the first column and the first row of the first column, and then scroll down, hit shift, and then click the bottom. That highlights that whole column. To get to the next column and skip this one, you want to use the control key. So I'm going to hold control, click the top, scroll down to the bottom. Don't hold the fingers down. Don't hold any keys down while you scroll. That's what makes things a little bit crazy in these sheets usually. And then hold shift and control at the same time to get the whole thing highlighted. Now that whole process might take some practice. That's fine, no problem. Okay, so now insert, and we're going to do chart. Now, nearly every chart in physical science should not be a line chart. It should be a scatter chart. I don't know why Google Sheets or any other spreadsheet program cannot manage this to just default scatter because it's the only thing that's really useful. And you can see, obviously, it doesn't look like a line because it wasn't a line, right? But while I'm here, let's do the real quick way of getting a line onto this formula, onto this sheet, this graph, and then we can check to see those values actually make sense. So on Google Sheets, you go to customize, and then let's see, I think it's series. Yes. Yeah. Okay. So you have error bars, data labels, and trend line is what I want to do. So I'm adding a trend line. There it is. But in order to see the equation, I have to go to label and then click use equation. And there's the equation. Does it match? 6.92, 6.92 minus 1 minus 1. Cool. So that is correct. So normally, of course, if you just want a line on your picture, this way is way faster, right? Using the graphical interface. But if you want to know how good that fit is, you can't get that at all via the graphical interface. You have to go back to this. So you really should be comfortable doing both. If you need to get the error, you should be comfortable doing this. But if a plot is fine, then this is obviously fine. Okay. That's all the introduction I want to do. I think that covers all the really powerful uses for spreadsheets in this class. And generally, it's like one of the most useful skills you could have your entire life as any kind of data. I mean, I want to say data scientist, but anybody who deals with data. I use spreadsheets to like keep track of my monthly cost in my house or how much my car costs over time or all this great stuff. Finances. I mean, really very useful. Spreadsheets are incredibly useful for all that kind of stuff. So I generally recommend them as something that every student, every person should be learning how to do if they want to keep track of stuff, Anyway, so hope this was really useful. This covers all the things we're going to need in this class, and will hopefully get you started. And again, keep this video around so you can refer back to it if there's something like, oh God, how did Dustin do that cut and paste thing? Okay, hope it was useful, and I will see you guys in class.